Hello and very welcome to 1286 of the series. It's another cloudy day, but it seems to be clearing up. I will continue today with Roberto, Unger and Smolin. And I have now entered into the Smolin section of the book. So Roberto Unger is behind us. And we'll see how it goes with Smolin. But last lecture, I think it went quite smoothly. But you'll be the judge. See, I think you need something to stand on. It's a bit softer. It's slippery. That will work. So I'll continue where we left off. Page 361. Timeless naturalism, on the other hand, holds that the experience of moments of time and their passage of flow are illusions. What really exists is the entire history of the universe, taken as a timeless whole. Now is as subjective as here, and both are descriptions of the perspective of an individual observer. There are similarly no objective facts of the matter corresponding to distinctions between past, present, and future. Timeless naturalism is similar but not identical to the view philosophers call eternalism. And temporal naturalism has elements in common with the philosophers' presentism. But my categories differ from the older ones because of an emphasis on the nature of law with regard to time. Timeless naturalism holds that the fundamental laws of nature are timeless and immutable. Temporal naturalism holds that the laws of nature can and do evolve in time, and that while there may be principles which guide their evolution, the future may not be completely determined. This is consistent with the claim that there are no facts of the matter about the future naturalism is an ethical stance to appreciate the import of such a change in our conception of nature. It is helpful to contemplate for a few moments how little we know about the substance of the natural world. When we say that as naturalists we believe in the existence of only the natural world, we are making first of all a negative statement. We do not believe in ghosts, spirits, heaven or hell. We don't believe in a separate mental world or the Platonic world of mathematics. But on the positive side, what exactly is it that we believe exists? We say matter, and indeed we know a lot about matter. For example, that the material world is constructed from atoms and radiation, which are in turn made of But what we know about elementary particles is the laws they satisfy, which determine how they move and interact. We do not know substantially what an electron is. By that, I mean we do not have any conception of the intrinsic nature of being an electron, except that its motion and interactions are governed by the Dirac equation and the Standard Model. But if we have no conception of the intrinsic existence of an electron, we have no such conception also of a rock. Thus we are open as naturalists to conceiving widely divergent conceptions of the natural. Some of us will say that there is no such thing in the actual world as the rock I'm holding in my hand. As it is, this instant, in the moment, that is an illusion. What exists is only the whole history of the rock taken as one. Others will assert the opposite, that all that ever exists is the rock in the moment. how are we to decide between two such different conceptions of nature, especially given that as naturalists we are committed to the use of evidence defendable within science? I would suggest that the most reliable test we have is the pragmatic one. Whichever view contributes more to the progress of our knowledge of the world is more reliable to take as a hypothesis for further explorations of nature. Given the fact that such divergent conceptions of nature are possible, it is helpful to give a definition of naturalism. Naturalism is the view that all that exists is the natural world that is perceived with, but exists independently of, our senses or tools which extend them. Naturalists also hold that science is the most reliable route to knowledge about nature. Part of my definition of naturalism refers to science as the most reliable path to knowledge about nature. This is unavoidable, as without reference to a conception of what it means to argue in good faith to a conclusion, it will not be possible to resolve disagreements between competing conceptions of nature. Note that my definition does not claim that science is the only path to knowledge, nor does it call on nor require that there be a scientific method. So I have to flesh out the definition by explaining what I mean by science as a route to knowledge about nature. Most importantly, I need to emphasize that while as Feyerabend convincingly argued. There is no scientific method. Science is most fundamentally defined as a collection of ethical communities, each organized around a particular subject. An ethical community is a community membership in which is defined by the holding and following of certain ethical principles. I have argued that the scientific community is defined by two ethical principles. A quote from myself. Scientific communities and the larger democratic societies from which they evolved progress because their work is governed by two basic principles. When rational argument from public evidence suffices to decide a question, it must be considered to be so decided. 2. When rational argument from public evidence does not suffice to decide a question, the community must encourage a diverse range of viewpoints and hypotheses consistent with a good faith attempt to develop convincing public evidence. I call these the principles of the open future. Naturalism is then in part an ethical commitment. To quote once more, science is the activity by means of which we display the same respect for nature that we aspire to show to each other in a democratic society. If naturalism is an ethical commitment, temporal naturalism is a deepening of it. Because it rejects the subversion of the naturalist impulse which occurs when a scientist substitutes nature in all its immediacy and primacy with an imagined world believed to be transcendent, but in reality just a construction of our imaginations. The naturalist stance is vulnerable to this kind of subversion because we know about nature second-hand through our sense impressions. Unless we are idealists, we do not believe that all that exists are our perceptions. What we believe is that our senses give us evidence for the existence of a natural world, which can be learned about through our sensations, but which exists independently of them. However, our senses and the experiments and observations which we carry out to extend them only give us direct acquaintance with the qualia, which are the sensory elements of our experience. Of the rest, they do not give us immediate acquaintance with or direct knowledge of the rest of the world. They can then only provide evidence for hypotheses which we make concerning the natural world. Thus, as naturalists, we are constrained to deal in indirect knowledge of the object of our study, and we must be always conscious that this knowledge is incomplete and never completely certain. But since we believe all that exists in the natural world, we must admit that incomplete and tentative knowledge is the best that can be had concerning what exists. Because of this, naturalists can hold quite strikingly different views about nature and still be naturalists. For example, many naturalists believe that everything that happens in nature is governed by universal and unchanging laws, but one doesn't have to believe this to be a naturalist. because we must admit the possibility that experiment could provide evidence for phenomena that are governed by no definite law. For example, if we believe that no hidden variables theory determines the precise outcomes of measurements on quantum systems, for which quantum mechanics is only gives probabilistic predictions, then we believe that there are phenomena that are non-law governed at all. Indeed, if we follow Conway and Kochen, then quantum phenomena are in a well-defined sense free. Or if we believe the standard Big Bang cosmology expressed in the context of classical general relativity, then we implicitly believe that no law picks the initial conditions of the universe. Or to put it another way, no law governs which solution to the equations of general relativity is somehow uniquely blessed with describing the actual history of the universe. Another thing that some, but not all, naturalists believe is that everything that exists in the natural world can be completely described by the language of physics. There are varieties of positions held with respect to emergence and reduction, but it is quite reasonable to believe that matter is made out of elementary particles which obey general laws, but that complex systems made out of many atoms can have emergent properties not expressible in or derivable from the properties of elementary particles. Many naturalists hold beliefs about the natural world that are more firmly held and expressed than the tentative nature of scientific hypothesis allows. These are often beliefs of the form. Our sense impressions are illusions, and behind them is a natural world which is really X. Such a view can either be an ordinary scientific hypothesis or a metaphysical delusion, depending on what X is asserted to be. When X is a statement like made of atoms, this is an innocuous scientific hypothesis which carries little metaphysical baggage and is in fact very well confirmed by diverse kinds of experiments. But statements of this form can be traps when X is a big metaphysical assertion which goes away beyond the actual evidence. A common and widely believed example is the claim that X, the universe, is really a timeless mathematical object. Whether that mathematical object is a solution to an appropriate extension of general relativity or a vector in an infinite dimensional space of solutions to the Wheeler-DeWitt equation of quantum cosmology, there is a big stretch from a statement of the form. Some experimental evidence concerning a specified range of phenomena is well modeled by a mathematical object O, which is a statement that might or might not be supported by evidence, and a metaphysical assertion that the universe is really a mathematical object, which is not by any reach of the imagination a hypothesis that could be tested and confirmed or falsified. What is troubling is that the statements of the form experience is an illusion and the universe is really X are common in religion. When naturalists make statements of this kind, they are falling for what might be called the transcendental folly. They are replacing the concrete, natural world by an invented conception, which they take to be more real than nature itself. Thinking like this turns naturalism into its opposites. Much that passes for naturalism and physicalism these days are instances of transcendental folly. I will continue with the landscape also by Smolin here. Just give me a sec. It's quite sturdy, written in 2013, but it fits very well here, where we are at page 366. I will put this Temporal Naturalism by Smolin. Two people may claim both to be naturalists, you hear, but have divergent conceptions of basic elements of the natural world, which lead them to mean different things when they talk about laws of nature or states or the role of mathematics in physics. These disagreements do not much affect the ordinary practice of science, which is about small subsystems of the universe, described or explained against a background idealized to be fixed. But these issues become crucial when we consider including the whole universe within our system. For then there is no fixed background to reference observables to. I argue here that the key issue responsible for divergent versions of naturalism and divergent approaches to cosmology is the conception of time. One version, which I call temporal naturalism, holds that time in the sense of the succession of present moments is real and that laws of nature evolve in that time. This is contrasted with timeless naturalism, which holds that laws are immutable and the present moment and its passage are illusions. I argue that temporal naturalism is empirically more adequate than the alternatives because it offers testable explanations for puzzles its rivals cannot address. It is likely a better basis for solving major puzzles that presently face cosmology and physics. This essay also addresses the problem of qualia and experience within naturalism and argues that only temporal naturalism can make a place for qualia as intrinsic qualities of matter. The subject of this essay is naturalism, the philosophical stance most closely associated with what might loosely be called the scientific worldview. My particular aim is to point out the role that our conception of time plays in the scientific conception of nature, and to advocate a particular form of naturalism based on an embrace of reality of time in the sense of the present moment and its passage. I will begin by defining the form of naturalism I advocate. Temporal naturalism, and distinguish it from its main rival, timeless naturalism. The view that what is really real is the whole history of the universe taken as one. Timeless naturalism includes the block universe interpretation of general relativity. One variant of it is the naturalism based on a timeless pluralism of moments advocated by Julian Barber. I then show that the choice of naturalism has consequences for the practice of science, particularly cosmology, due to the implications of the nature of time for the conception of laws. Timeless naturalism is similar to the view philosophers call eternalism, and temporal naturalism has elements in common with the philosophers' presentism. But my categories differ from the older ones, among other reasons, because of an emphasis on the nature of law with regard to time. This essay is part of a larger project whose aim is to radically reconfigure the practice of science on a cosmological scale to admit three theses. One, the reality of time. Two, the evolution of laws with respect to that time. And three, the uniqueness of a single causally closed universe that unfolds in time. This project was conceived with Roberto, Mangabeira, Unger, and its main vehicle is a book jointly written with him, to which my book, Time Reborn, may serve as an introduction. It is the combination of the three theses that makes this not just a rerun of the old presentist eternalist debate. In particular, a major claim of naturalism is that temporal naturalism has a much larger range of empirical adequacy than its rivals, because only it allows a conception of laws which can evolve in time. This, we argue, is necessary if we wish the choice of laws to be explicable on the basis of hypotheses that are falsifiable by the results of doable experiments. The present essay summarizes the main arguments of 2 and 1, and then advances the program in 2 directions. 1, recent work with Marina Cortes has emphasized 3 aspects of a reconfiguration of cosmology within temporal naturalism. 1, framing the fundamental laws, framing the fundamental laws as asymmetric and irreversible in time. Drawing out the consequences of an insistence on the uniqueness of elementary events, an underexplored consequence of Leibniz's principle of identity of the indiscernible. And 3, finding a role for energy and momentum as necessarily intrinsic quantities within a relational universe. One consequence is an elegant solution to the long-standing problem of getting classical space-time to emerge from a semi-classical limit of the theory of causal sets. 2, as emphasized by Galen Strawson and Thomas Nagel, naturalism must have a role for qualia and experience if it is to live up to its defining aspiration that everything that we know that exists is part of the natural world. I argue below that only temporal naturalism can accommodate qualia and experience as intrinsic qualities of events in nature. What is naturalism? Let me start with a definition. Naturalism is the view that all that exists is the natural world that is perceived with but exists independently of our senses or tools which extend them. Naturalists also hold that science is the most reliable route to knowledge about nature. Well, this is a first good try at a definition, but its simplicity hides ambiguities and traps. Unless we are idealists, we do not believe that all that exists are our perception. What we believe is that our senses give us evidence for the existence of a natural world, which can be learned about through our sensations, but which can exist independently of them. However, our senses and the experiments and observations which we carry out to extend them only give us direct acquaintance with the qualia, which are the sensory elements of our experience. They do not give us immediate acquaintance with or direct knowledge of the rest of the world. They can only provide evidence for hypotheses which we make concerning the natural world. Thus, as naturalists, we are constrained to deal in an indirect knowledge of the object of our study. And we must always be conscious that this knowledge is incomplete and never completely certain. But since we believe all that exists is the natural world, we must admit that incomplete and tentative knowledge is the best that can be had concerning what exists. Because of this, naturalists can hold quite strikingly different views about nature and still be naturalists. For example, many naturalists believe that everything that happens in nature is governed by universal and unchanging laws. But one doesn't have to believe this to be a naturalist, because we must admit the possibility that experiment could provide evidence for phenomena that are governed by no definite law. For example, if we believe that no hidden variables theory determines the precise outcomes of measurements on quantum systems, for which quantum mechanics only gives probabilistic predictions, then we believe there are phenomena that are not law-governed at all. Indeed, if we follow Conway and Kochen, then quantum phenomena are in a well-defined sense free. Or if we believe the standard Big Bang cosmology expressed in the context of classical general relativity, then we implicitly believe that no law picks the initial conditions of the universe. Or to put it another way, no law governs which solution to the equations of general relativity is somehow uniquely blessed with describing the actual history of the universe. Another thing that some, but not all naturalists believe is that everything that exists in the natural world can be completely described by the language of physics. There are varieties of positions held with respect to emergence and reductions, but it is quite reasonable to believe that matter is made of elementary particles which obey general laws, but that complex systems made out of many atoms can have emergent properties, not expressible in or derivable from the properties of elementary particles. 1, 2. Naturalism through the looking glass. Many naturalists hold beliefs about the natural world that are more firmly held and expressed than the tentative nature of scientific hypothesis allows. These are often beliefs of the form: our impressions are illusions, and behind them is a natural world which is really X. Such a view can either be an ordinary scientific hypothesis or a metaphysical delusion, depending on what X is asserted to be. When X is a statement like made of atoms, this is innocuous scientific hypothesis which carries little metaphysical baggage and is in fact very well confirmed by diverse kinds of experiments. But this was, of course, not always the case. But statements of this form can be traps when X is a big metaphysical assertion which goes way beyond the actual evidence. A common and widely believed example is the claim that X, the universe, is really a timeless mathematical object. Whether that mathematical object is a solution to an appropriate extension of general relativity or a vector in an infinite dimensional space of solutions to the Wheeler-de Wit equation of quantum cosmology, there is a big stretch from a statement of the form. Some experimental evidence concerning a specified range of phenomena is well modeled by a mathematical object, O, which is a statement which might or might not be supported by evidence, and a metaphysical assertion that the universe is really a mathematical object which is not by any reach of the imagination a hypothesis that could be tested and confirmed or falsified. What is troubling is that statements of the form experience is an illusion, the universe is really X, are common in religion. When naturalists make statements of this kind, they are falling for what might be called the transcendental folly. Maybe I like Smolin. His arguments are a bit more punchy. One could imagine he's a New Yorker like Feynman, but I don't think he is actually. They are replacing the concrete natural world by an invented conception which they take to be more real than nature itself. Thinking like this turns naturalism into its opposite. Much that passes for naturalism and physicalism these days are instances of transcendental folly. A system of the transcendental folly is the move from sense impressions give unreliable knowledge of nature. Nature is instead truly X. To sense impressions are incompatible with the concept that the world is X. So qualia must not exist. But one thing we can be sure of is that qualia exist. Therefore, as Galen Strawson and Nagel, philosophers of mind, emphasize, that if we are naturalists and believe everything that exists is part of the natural world, then qualia must be also part of the natural world. The right statement, if we are naturalists, must be X may provide a good description of some class of observations of the world, but the world cannot be X exactly because qualia are undeniably part of the world and X are not qualia. This is especially the case when X is a mathematical object. Poor trademark. Naturalism is an ethical stance. Part of my definition of naturalism refers to science as the most reliable path to knowledge about nature. Note that my definition doesn't claim that science is the only path to knowledge, nor does it call on or require that there be a scientific method. So I have to flesh out the definition by explaining what I mean by science as a route to knowledge about nature. Most importantly, I need to emphasize that while, as Feyerabend convincingly argued, there is no scientific method, science is most fundamentally defined as a collection of ethical communities, each organized around a particular subject. An ethical community is a community membership in which is defined by holding and following of certain ethical principles. I argue that the scientific community is defined by two ethical principles. Scientific communities and the larger democratic societies from which they evolve progress because their work is governed by two basic principles. When rational argument from public evidence suffices to decide a question, it must be considered to be so decided. 2. When rational argument from public evidence does not suffice to decide a question, the community must encourage a diverse range of viewpoints and hypotheses consistent with a good faith attempt to develop convincing public evidence. I call these the principles of the open future. Naturalism is then in part an ethical commitment. Relationalism. I'm a Leibnizian, which I take to mean that I find the following of his principles to be very helpful to frame the search for a correct cosmological theory. 1. Principle or aspiration for sufficient reason. 2. Principles of identity of the indiscernible. Principle of causal closure. The universe contains all its causes. 4. Principle of reciprocity. If an element of nature A can influence change in element B, the reverse must also be the case. Leibniz's principles underlie the philosophy of relationalism, which claims that at least some physical quantities, particularly space and time, are defined only by the network of the relationships that weave physical reality into a whole. However, I am not a relational purist. That is, someone who believes all physical quantities are relationally defined. There can be intrinsic qualities as well, and among these, I will argue below, are energy and momentum. Another class of intrinsic qualities I will discuss are qualia. I call the principle of sufficient reason and aspiration, because I believe its use for science lies in motivating us to attempt always to invent hypotheses and theories that will increase our understanding of the reasons for the universe is the way it is. General relativity is the best example of its power. and it continues to underlie developments in quantum gravity as the desire that our theories be background independent lies in our understanding that there can be no sufficient reason for background structure in a fundamental theory. And as I explain here, the desire for sufficient reason underlies our insistence that there must be a causal explanation for the universe's choice of laws and initial conditions. At the same time, the fact that it is generally good advice to seek to come closer to sufficient reason in no way commits us to the belief that sufficient reason must be completely obtained by a cosmological theory to judge it as a success. In fact, there is a tension between the demand for total sufficient reason and the insistence that there is a single universe, unique in all its particularity. We must admit the possibility that there may be many details of how the universe is that are simply the way it is. Indeed, if the current models of inflationary cosmology are right, then the details of the structure in the universe are seeded by quantum fluctuations of fields during inflation, which, on the standard interpretations of quantum theory, are truly random and hence have no sufficient reason. Nor is it obvious it would increase sufficient reason to explain these in terms of hidden variables, as this would likely just add to the burden carried by the initial conditions. And there is a further tension between sufficient reason and the demand that the future be partly open, which is also part of the temporal naturalism endorses. It is best then to decouple the heuristic usefulness of the search for sufficient reason from the knotty question of whether there is ultimately complete sufficient reason by speaking of a principle of differential sufficient reason, it is always good advice to seek to increase our understanding in ways that bring us closer to sufficient reason. The principle of reciprocity was introduced by Einstein as part of the motivation for general relativity. I will widen its application to criticize the idea that laws of nature are immutable if they act to cause events to happen, but in turn cannot be changed or modified by anything that happens inside the universe. However, note that I will allow an important exception to this principle, as I will posit that the past influences the present and future, but the reverse is not true. No event in the past can be affected by anything that happens in its future. Finally, I will apply the principle of identity of the indiscernibles not, as is sometimes done, in the context of possible worlds where it is false, but as a criteria our single, unique, existing universe must satisfy. Thus, while it is possible to imagine possible universes that have symmetries that render two or more distinct events indiscernible, I will argue that such symmetries must be absent in the one real universe. Naturalism, time and laws. In this essay, I am interested to tease out distinct kinds of naturalists which differ because of different views as to the nature of time, as well as the relationship between time and laws. I will mainly discuss two views which I will call timeless naturalism and temporal naturalism. I discuss each in turn. Timeless naturalism, which is the most common thing today. Open a study book and you will find that. Timeless naturalism holds that the experience of moments of time and their passage or flow are illusions. What really exists is the entire history of the universe taken as a timeless whole. Now is as subjective as here. Both are descriptions of perspectives of an individual observer. There are similarly no objective facts of the matter corresponding to distinctions between past, present, and future. Timeless naturalism is closely related to the block universe interpretation of general relativity. That interpretation is supported by arguments such as that of Putnam, who hold that the relativity of simultaneity implies that any property of a moment must be shared equally by all moments. Timeless naturalism holds that the fundamental laws of nature are timeless and immutable. To avoid confusion, we should recognize that there are several different versions of the block universe idea in the physics and philosophy literature. The physicists' block universe assumes that the universe's history is the result of deterministic and immutable laws acting on initial conditions. And this is what I will refer to when I speak of the block universe. Within this conception of the universe, nothing can be truly novel because any observable measuring a property of the universe at a future time can be expressed as a function of observables at any earlier time by inverting the equations of motion. The special relativistic block universe is a special case of the physicists' block universe, where simultaneity is relative, so the argument of Putnam against presentism can be run. Even stronger is the general relativistic block universe, where the assumed spatial compactness plus space-time diffeomorphism invariance implies that any observable at one time is gauge equivalent to observables at any other time. That is, observables at different times are mathematically different but physically equivalent ways to describe the same facts. Some philosophers defend a very much weaker notion of a block universe, which is just the collection of all facts that will ever be the case at some time or another, irrespective of whether the laws are deterministic or not, or changeable or not, or as it is sometimes put, wait to the end of time and then represent all that has been the case in a single mathematical representation of the universe's entire now past history. This is a metaphysically fanciful notion whose relevance to any issue of physics can be denied by just saying no to the existence, interest, or validity of the viewpoint of an observer, not only outside the universe, but also beyond it, temporally and causally. But allowing this philosopher's block universe into discussion, it is clear that, as is claimed by philosophers, there is no contradiction between it and any notion that laws evolve. This is true, but it is not the notion of a block universe that physicists speak. So when I use the word block universe in this paper, I mean the physicist block universe, and unless otherwise specified, I mean it in the strong form of the general relativistic block universe. The physicist's block universe is then a description of the timeless reality which compromises the history of the universe taken as one. That timeless naturalism asserts is what is real. Can timeless naturalism recover our experience of the world? To be at all a candidate for a description of our world, timeless naturalism has to answer a simple question. How does the sense of experience the world as a set of moments arise from a world with no conception of time? Carnap addresses this while recounting his conversations with Einstein on the great scientist's disquiet with the absence of a conception of the now in physics. The peculiarities of man's experience with respect to time, including his different attitude towards past, present, and future, can be described and in principle explained in psychology. I believe a few moments' thought suffices to convince us that it will require more than a call on psychology to satisfactorily answer this question. Two very different kinds of claims would need to be made and defended before Carnap's aspiration can be fulfilled. First, it has to be established that there are any facts in the block universe corresponding to events that are local in both space and time, as is the case with our experiences. For once it is asserted that what is real is the whole history of the universe, taken as one. It is not obvious that there are any purely local facts or observables. The second point that must be argued is that the block universe picture can explain all the features of our experience. Some proponents of eternalism hold that the timeless universe contains temporal parts which are local in time, and that some of these correspond to moments we experience. Others hold that we experience the world through moments and remember the past, but not the future, is an evolutionary adaptation which arises to make information gathering and utilizing subsystems more efficient and hence more fit. Although the extent to which this argument is not circular, because it assumes an evolution in time, is a subtle question. But it can't be this simple, because whether or not one can simply assert that there are local observables in the block universe picture depends on physics. Newtonian physics is local in time, and so are its observables. But things are not nearly so simple in general relativity. While it's true that Einstein's field equations are local in space-time, the observables are generally not, because reality corresponds not to a solution of the field equations, but to an equivalence class consisting of the infinite number of solutions rendered equivalent under diffeomorphism. This raises an important point I will develop below, which is that to refer to any local event in general relativity requires giving a complete specification of information sufficient to distinguish it from all other events in the space-time. This is required to refer to an event uniquely in diffeomorphism invariant fashion, and it can also be seen as a realization of the principle of the identity of the indiscernible. The key point to note is that any such local observable must then be defined relationally, and it is also contingent because the conditions that uniquely specified a particular event may not obtain in every solution of the field equations. I raise below the question of whether our subjective experience can ever be associated with such a relational and contingent description. If this worry can be resolved, and I think I stopped mid-sentence this time, a little bit of a cliffhanger. He's different in his writing style to Roberto Unger. He do carry a significant punch, which I like. And I do recommend his videos as well. He's rather witty. I say thank you very much. And I wish you all a very, very pleasant afternoon. As you can spot, there's still leaves on the rose hips. The roses, I should say, maybe.